some requests.
Let's do some requests.
Now it's recording. You're going to have to ask the question again,
Okay.
Jessica.
Hello, Joe. Would
Hello,
it be
Jessica.
possible to make some requests?
Yeah.
Great. Could we start very high level?
What is
and then
your
go-
request?
Could we start very high level and then go deeper and deeper?
That
And,
sounds good.
and would you mind talking a little slower so that it takes time to connect?
I will
dots
talk
in the
annoyingly
brain?
slowly. Okay.
Great. Thank you.
Let's go from the very, very top. Giant Swarm is the company that you all work for, and we provide a product and a service. Bada bing, bada boom. The product is this whole Kubernetes control plane thing. The service we maybe get into if we've got time, but let's go with the product because that's the main thing in terms of architecture. So let's start from, I guess, from a Kubernetes cluster. So a Kubernetes cluster has a master, which is what you talk to get it to do stuff, and a number of workers. You got a fucking ton of these motherfuckers. These talk together, you talk to the master, and then you schedule some stuff. We can go into that further, but I just want to get the idea of a cluster. At Giant Swarm, we call these tenant clusters. And these clusters are what we run for our customers. Easy. Then we have the idea of our actual product, which is this Kubernetes control plane, which also runs in a Kubernetes cluster. And each control plane has a bunch of stuff in it, which you can kind of roughly break down into APIs, so how we talk to the control plane, some operators, which is a Kubernetes pattern we can go into, and some monitoring, which is how we can tell if things are going well. So a control plane is a bunch of stuff that looks after a few tenant clusters. I don't know what the upper limit is. I think it's like 50 or like 100 or something. Sorry, I'm drinking my tea. Give me a second. A control plane and a whole bunch of tenant clusters together form an installation. And we have a fucking ton of these, like 20, 24, 25. And those are what we actually sort of sell. Yep. Any questions? That's the super duper high level, what's our fucking thing? We install a control plane, and that provides tenant clusters, which customers use. Yep.
Why is there only one master?
Is a high level question we're going to go into a bit later. Tenant clusters. Let's keep going down into the control plane though. So there are two things here. There is the Kubernetes API, or APIs, which our customers use. So they can use kubectl and they can say, here's a deployment, run some of my applications. There's also the Giant Swarm API, which runs on the control plane. So this is where they ask for stuff like, give me a cluster. Whereas here is what they ask for, sort of, deploy my service. So this API is essentially, well, the Giant Swarm API is kind of our product. Like, we provide this API, it can manage clusters. All of those clusters on the service side are managed by us, whatever, but that's on the service side of this. The product is here. So if we start breaking down the control plane, let's have some things. So there's the API, there's operators, and then there's monitoring. And just for the sake of making things easier, I'll start with AWS and I'll show like where the differences are. So some user somewhere, let's call him Jimmy, is going to make an API request. We have a service called API, which is super not confusing for everyone, but we do. And this is a sort of gateway, if that makes sense. It is the first thing people talk to, and then it'll start branching off into a like a microservice architecture. So there's a whole bunch of other API services. So another main one is cluster service, which does a lot of business logic and stuff like this. Takes care of key pairs and etc. etc. Another one is Kubernetes D, which I think means like the daemon for Kubernetes, but it's just a really old way of saying stuff. And that has a lot of stuff to do with like Kubernetes management. So it talks directly to Kubernetes, whereas cluster service doesn't most of the time. And there's also a whole bunch of other ones. So for example, we have user D for user management, and company D for organization management. So this whole like multi-tenancy, that's there. There's token D, which I just don't remember what it does. It's something to do with logins. Those are probably the main ones. So essentially, people talk to the API, and it goes through a whole bunch of these things, and that's how we sort of present our API. At the end of the day, that ends up creating a Kubernetes custom resource, which I should probably go through before we go through this. So let's have a bit of a segue. That's not how you spell that, but fuck it. For operators. So if you have a sort of more traditional microservice architecture, you'll have something where you have some user sends a request to some service, and then you'll have a response. And this might go back to some other services as well. And this will all operate on some sort of like RPC, HTTP kind of thing. So like HTTP, JSON, gRPC, these are all the kind of ways of doing it. That's really good for when you've got sort of like requirements towards like low latency, a kind of event-driven kind of thing. But what it really kind of sucks at is when you want to do infrastructure. Because let's say you want to declare that you want a machine to be running. So here, for example, you would be sort of, you know, as person here asking the service, it would launch a machine, and then that would be the end of it. There's no lifecycle management. We'd need to have something that like continuously checks that these machines are how we want it to be, which is where operators are really good. So operators take a custom resource. So we call it a CR most of the time. And then it will take this as a form of desired state. So Jimmy, instead of sending a request to the service, writes down what he wants. The operator then continuously checks this against some kind of actual state. So in this sort of like very contrived example, what it looks like is Jimmy writes down that he wants a virtual machine. The operator then sees that CR and goes, hey, you want a virtual machine, but that doesn't exist. So I'm going to go to the cloud and create one. And then the operator goes back and then writes in the CR sort of, hey, yeah, I've done this. It's all good. And then it consistently checks that actual state against the desired state. So if in the future that virtual machine disappears, it'll actually recreate it, which is really good because it's really good for these kind of situations that we have where people say they want clusters and we need to make sure that we have clusters for them, but also that they don't break over time. So we use this pattern all the fucking time. Like literally 80% of our code is in operators. So one example you've probably seen is heard of at least, is the AWS operator. So somewhere here, I think it's Kubernetes D, will write a CR that is consumed by the AWS operator. So the user says, I want a cluster. It goes all the way through the microservices to Kubernetes, where we write down this custom resource saying, hey, I want an AWS cluster. the AWS operator talks to, or sort of sees that desired state in the custom resource, goes, hey, I need to talk to the AWS API, because that's our kind of source of actual state, and goes, creates a cluster. So for this, we're using like CloudFormation mainly as a sort of way of defining like the entire cluster at once. And then this also works like in reverse, if that makes sense. So once that's up, users can see that sort of actual state as part of our API. And there's a whole bunch of other operators as well. So for example, cluster operator does a bunch of work with certificates. So making sure that the certificates are present, that Vault backends exist. There's one called node operator that does a lot of work towards managing nodes in a Kubernetes cluster during upgrades. There's at least a billion others that I'm forgetting because I'm doing this quickly and I did very well.
Joe, is
Yes.
there one called Orange?
Porridge.
Orange.
Orange.
Yeah.
As in the fruit?
Yeah.
Orange
There is
glad
no
didn't say banana.
I don't know of
my
an orange
God.
operator.
But somebody. Okay. Maybe that's something else.
It's a
Orange
customer.
is a customer.
Nah.
Yes.
Okay, don't worry. It was
Okay.
the other day when we were dishing out PMs. I thought it was related to operators. Okay, no worries.
No worries. And there's a few more that I can't remember. See GitHub. Then finally, we have a whole bunch of that sort of the third pillar of monitoring. So for us, a pretty big backbone here is Prometheus. What that does is, okay, I'm also going to just put here that we have a tenant cluster because then my lines add up. What Prometheus tends to do is just talks to all of the tenant clusters. So this whole idea of scraping data over time, that sort of pull-based thing. Prometheus talks to all the tenant clusters and then gets time series data, and then via Alert Manager, will then send it to me, only me. And that's the crazy architecture at a super high level view of how the whole thing works in 30 fucking seconds. Yeah. Hello. Good day. Questions? I will just keep talking randomly until someone says something.
Banana.
Okie doke. Then let's go into how we deploy stuff. Because this is about 3 different things all happening at once. So, Giant Swarm has some interesting problems here. So your traditional way of doing this is going to be, you have some hacker somewhere who puts code on GitHub. Then when that happens, you'll have some CI tool that runs and ideally pushes some artifacts to a registry. And then also pushes to production. Yeah, that's a sort of traditional CI pipeline in 30 seconds. The issue with Giant Swarm we have lots. That's not how you spell lots. That's just a hash sign. We have lots of productions, if that makes sense. So right now we have like 25 installations, as opposed to say like most people who have 1. And then also some of them are on-prem. The issue there is we wouldn't be able to push. So our CI servers run in AWS. They don't have network connectivity to on-prem servers. We can't really install the VPN there. There's just no way to sort of like connect the dots. So the way we this is the classic, if you've heard of the old man draftsman way of doing things. What we do is in each, I have a good idea of how to draw this. Yeah, cool. So I push some code to GitHub, or specifically I merge to master. GitHub will then build my application and push images and charts to Quay. Quay is what we use for our registries, for holding like images and charts. It's some Red Hat product or IBM product nowadays, but it just works pretty well. And then the issue we have is we have some control plane cluster, or actually we have like a fucking ton of them, that exists out in the world somewhere that we can't actually tell that it needs to do anything with. So we have a application running there, a sort of daemon called Draftsman. And I don't remember why he's called Draftsman. I think it was because a draftsman is like an architect, and that was the name of the other tool. So what we do is in GitHub, we create a deployment. It's a kind of GitHub object, if that makes sense. So it's data stored in GitHub. So we'll create a deployment event for, let's say I'm building the AWS operator. We'll create a deployment event for the AWS operator, and we'll create one for every control plane or for every installation. Oh yeah, this will be a fun fact. I've just frozen. Hello?
We're here. We can hear you.
There we go. I can scroll. So, no one asked, but I remembered. We have 20 odd installations, and identifying them is a problem, if that makes sense. Like, what are they called? Where do they exist? We went back and forth for ages. What we've ended up now is we have a scheme called code names. So this originally started with us not being able to, I think when we had like Vodafone and Adidas, but before we were allowed to talk about them, not being able to say the word Adidas in like a public setting. So we came up with Viking for Vodafone and Asgard for Adidas. And then when we needed names for installations, we just used those names. So the Vodafone installation became Viking, and the Adidas installation became Asgard. Every installation has a code name. They have to be short. They have to be easy to spell, especially if English isn't your first language. And the first character of the code name is the same as the first character of the customer. So Viking is V for Vodafone. Asgard is A for Adidas, etc. Which is super useful because then you actually just fucking remember these things as opposed to having some silly name. So we'll create a deployment for the AWS operator for Asgard and Anubis and all the way down to Victory, which I think is our last one, or Viking, whatever. Draftsman watches GitHub for these events. And if this is Asgard, it will see that deployment for its own cluster. It'll see that it's for the AWS operator, and it'll pull the image and the chart from Quay and install them. That's how we used to do it for a few years. We still use this for like most things. But there are some drawbacks, primarily to do with like specific release management. Draftsman always just installs the latest of everything. So this is where you'll probably hear some stuff towards like managed apps. And also Vue kind of sits here a little bit as well. So with managed apps, we can't use Draftsman because you kind of need to, it doesn't really install stuff on demand. You kind of have to set it up with what you need to install, and then it installs it. So managed apps works a bit differently. So you have an API, you have Happer, which is our web front end. So in Happer, you click to install. That sends a request to the API, and I forget exactly what that workflow is here. But at the end of the day, we end up with an app CR. So this is a custom resource that declares, you know, I want this app installed. And it's got some fields in here like which app, I think versions, and so on. The app CR does nothing by itself. What happens is we have an operator called app operator that operates on apps, or it apparates. Ha 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 ha. App operator talks to the app CR, does a bunch of magic, and creates what we call a chart CR. I think it also talks to a registry here to get like specific versions. or at least a catalog. Lukash probably knows more about this than I do at this point. To create a chart CR. The idea between having the difference between an app CR and a chart CR is a app CR is a sort of more abstract concept. It's like, I want this app installed, whereas a chart CR is a specific chart we want installed. So you can think of a chart as like one version of an app, whereas an app is more sort of like a large scale concept. This then talks to a chart operator, which is again sort of doing more specifically stuff. That definitely talks to the registry. No, that doesn't talk to the registry because I'm going too far. That talks to Helm, which is a fairly popular tool for Kubernetes for, I guess, the de facto package management tool, which actually then installs the chart completely. So that's the newer way, and that's the sort of managed apps way which Team Batman is building currently. And the idea is essentially more flexible, much more Kubernetes native. Like, we actually have some operators running here. You can just create, like, the nice thing is you can just create an app CR like as you need to. Like, for example, as part of Vue, we do a bit here. Like with Draftsman, you essentially can't just deploy something on demand. It has to be sort of integrated a bit. Cool. Questions? I'm just going to keep talking about random topics if no one says anything. Fine. Great. Simon did have a question. Let's fucking cover that at this point. So once you start getting into the actual tenant clusters, what this essentially looks like is having one master in a high level and some number of workers. Inside the workers, you're running, the big thing, I guess, is the kubelet, which is it's from Kubernetes. It's a Kubernetes component. And the idea with the kubelets is they're the things that sit on the workers and actually run workloads. So they really only talk to Docker as part of like starting a container. I won't go too much into like container details at this point. On the master, though, you have all the Kubernetes control points. So an API server, I'll go into the specifics, a controller manager, a scheduler. So the API server is what you talk to as a user of Kubernetes. All the components in Kubernetes talk to the API server. They don't talk to each other. A controller manager talks to the API server. The controller manager takes care of, it's essentially an operator. It's the same pattern. So for example, with app CRs, where you'd have the app operator reconciling an app CR into a chart CR, the controller manager is what takes care of reconciling a Kubernetes deployment to a replica set, or a replica set into a pod. So a lot of these built-in Kubernetes resources, the controller manager is what takes care of reconciling them. And schedulers are pretty different. Schedulers take care of reconciling unscheduled pods to becoming scheduled pods. It does this using a fucking ton of math that I don't understand. Fine. The kubelets also talk to the API server and then kind of essentially ask, what should I run? And reporting what I am running. So you see here, we've got this continual pattern of desired, what should I run, and reporting what I'm actually running, the actual. Same with the controller manager, asking what's the desired state, creating actual state. Same with the scheduler, asking for desired state, creating actual state. The brains behind all of this is etcd, which is a silly name for a quite important thing. etcd is a database. In a nutshell. Specifically, it is a key value, consistent and partition tolerant distributed database. What this means is if you had a database only running on one machine, you start having issues when that machine dies because it's dead and you can't talk to your database anymore. So this is where distributed databases come into play. So with etcd, you can run it over multiple machines. And you start getting into a lot of the theory of distributed systems here. like computer science stuff that people get paid to do. The main thing here is by being a consistent database. If I talk to at T0, if I write to this one, if then at T1 I read from a different etcd, let's say I write X here, if I read it, I'll get X here, even though they are separate machines. And also with being a partition tolerant, if, say, the connection breaks here, it still keeps working. This makes it super difficult to manage. All of this magic shit here, which is full-on computer science crap, means that managing particularly automated multi-node etcd clusters is very difficult. It's super easy to fuck this. So at Giant Swarm, we currently only run one etcd per tenant cluster. We do not have a multi-etcd setup. You can essentially, this is one of these points where there's a degree of pragmatism. So if you need, how do I say this correctly? Most of the time, you don't need to talk to a Kubernetes API server. You only really need to talk to an API server if you're doing stuff to change the state of a cluster. Kubernetes is designed in a way that if the API server disappears, everything will just keep running as it is. Like, you won't have any sort of event changes, stuff like that, but the whole thing keeps going. So you only need to talk to the API server when you're making changes. And this also includes like scaling the cluster up and scaling the cluster down and stuff like this. For most people, a rough SLA of 99% is good enough. Having this sort of multi-master setup with multiple etcds takes you to 99.99%. This difference here is not enough realistically to make it cost effective for most people. There are some customers who are probably asking for this, and I don't think they personally know what they're talking about. You have to be doing a lot of work and having a lot of specific problems for this to become worth it.
Yep.
So that's why we're currently doing it. I mean, HA Masters is on our roadmap, and they'll be good to get it done, but it is not the killer that people think it is. Cool. More questions. Let's go. Come on. What time is it? Oh, fuck me, I've been talking half an hour. Okay, I need like 2 minutes.
Joe, would you be able to do a high-level summary, like high-level bullet points of what you just explained to us, please, so that I can put them all into little boxes in my head? You just went, blah, blah, blah.
Okay, what didn't you get? I can go into further. Start from the top.
And just like a high-level summary.
Okay, let's go for the top again.
I just need to, what's the word?
So,
Well, Joe, take another minute if you need. I think
I'll finish my tea. Let's have a break for 2 minutes. I also need to pee.
I just muted you, Jessica. I was not keen on listening in on the Spanish conversation.
Locals. Yeah. It's a little Spanish coffee shop, about 2 minute walk from my house, and it's the old man local. And I don't think they've ever seen. I stick out like a sore thumb here. They're all staring at me. They've never seen an online meeting like this before. I think I think they finished work or something. What? You're on mute, Simon.
I said it is Spain, and at 3:03, who's working? So.
Yeah.
Did you guys ever watch Bob Ross?
Yes.
This feels very Bob Ross-esque,
You haven't been calm or slow enough for that, Joe.
Yeah, I know. I just get into it, guys.
We don't make mistakes, Joe. It's just a happy little.
It's a happy little mistake.
Happy little accident. Let's just put some trees over there.
Let's have some little trees, guys. Come on. Where are the trees at? Hey, trees are brown, aren't they?
Depends.
There we go. There's Bob Ross.
Here we go. Here we go. You've already succeeded today because you're the only person who can be you. Cool. So let's
I'll mute
just...
you again, Jessica.
Okay.
Oh, I don't remember who thought up axolotl. Vatslav, I think. We needed an A that was Chinese, I think. And
easy to
axolotl.
spell.
I think axolotls are close to dragons because they're salamanders, or they have that weird thing, aren't they, where they're like salamanders that regressed like evolutionarily or something. But I don't think it's actually. I don't think there's actually. I don't think axolotls actually come from China. I think they're only in like Mexico or something.
Joe, if I may, just because assuming this may have been. Wait, stay here. Just to make it clear, every customer has a control plane. This control plane is nothing shared. You want to go into that point a little bit quickly?
Yeah, let's go for that.
Cool.
Actually, let's just sort of recap the whole thing. So, Giant Swarm operates a number of installations. A installation will be per region
environment.
Or environment is kind of the way, but I want to be a bit more specific. So we'll install one per cloud region or per on-prem data center in a sort of very general sense. Let's go into why that is in a second. Let me write a note. Why separate
Control planes.
installations? Every installation has one control plane, so one Kubernetes cluster that hosts our services for managing tenant clusters. That control plane then has a number of tenant clusters. So I guess it looks kind of like Giant Swarm. We take care of a lot of installations, which will have one control plane and fucking infinite tenant clusters. Boom.
Oh, I have a question.
Sure.
It's kind of a clarification comment.
Fine.
Quick question. The SRE, sometimes Vaslav, for example, he's in Firecracker, he has to do an installation. This is the SRE's job.
Sure. I think we're currently casting it under the SRE of the week responsibilities. So we'll have an installation and the SRE of the week takes care of it. We're probably changing that because some on-prem installations may, take more than a week and you kind of want the same person on it. But on the whole, SREs take care of installing stuff. Sure.
They do partner on this front with the SE though.
Yeah. It's not just like on their own kind of thing.
Yeah.
And I think I interrupted.
Nah, you can't interrupt me.
Oh, okay. How kind of complicated is this? How many days work? Is it really tricky to learn how to do an installation?
So that's a testing question. For clouds,
Yeah.
it is pretty easy. Or let's go with straightforwards. I forget the exact details here in terms of specific technology. But for clouds, we just have a Terraform setup that installs the control plane Kubernetes cluster in a sort of very high level sense. We then use Draftsman to install the services, and then you're pretty much good to go. So I think we're looking at the order of days for a cloud installation.
All you really got to do is make sure there's one in the link that the customer has provided us with checks to the checklist.
Yeah, sure. Like there is the very big possibility of the customer blowing it up a little bit. And there's also some stuff where different regions have different issues. So for example, China is the just amazing version of this where some services just aren't missing. Sorry. Some services aren't there. Or they are missing. So hello?
Is Joe lagging or me?
Joe.
Okay.
Hello?
We can
We hear you, Joe.
now. Yeah, we
Hello,
can hear
people.
you now.
Hello, I love you. I've missed you already. So China's a good example here, where there are just some services missing, and like even silly stuff. Like I remember we did like the Seal installation. There was something silly there with like some dumb AWS thing that just made it take longer. So there's a fair amount of leeway on these things. This is sort of something that do you remember we had the story of like control plane operators? And there's also some other stories to do with like control plane management and automation and just making this whole thing a lot easier, because that's not very straightforward. On-prem, it is a fucking completely different beast. And I would say an
now I
on-prem
understand, because
installation.
sometimes it sounds like, I'm doing an installation in the standards. Never times like I'm doing an installation. So now I understand why sometimes it's more complicated than others.
On-prem can take from 0 days to, I'd say, on average, 10,000 days. That's probably a realistic way of how we can plan that.
Which is why the Börse Stuttgart installation, which is on-prem, went roughly 90 days to in production, and everyone was just like, wow.
90 days is good. I mean, Panamax. So the issues here are numerous. The way we kind of doing this is we have, a server, we call it a Pixie boot. We put that in the servers, we launch everything, and they come up as a Kubernetes cluster. And we, again, use Draftsman to install all the services, roughly. The issue is that on-prem, every on-prem is different. They have like weird networking requirements. Sometimes the DNS just isn't right. So like networking requirements, forgetting how DNS works, storage, PXE boot is, why would you, when you can literally say the word Pixie as like part of your work.
Pixie, but I've heard it too often now.
PXE is just sad. Call it a Pixie boot. Fine. So this can just take forever. Draftsman, pum 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 pum. So yeah, that's why installations can just take long, because it's like, trying to build a boat and then putting it into someone's like front room. Everyone's front room looks different.
But why would we want to continue with? We're going to have another Kubernetes team that's on-prem. Why? If the installations is
the really big thing. Wait, what was that? Installation should be a thing.
But why are we going to have more on-prem?
Well, I mean, the big thing there is on-prem is a differentiator for us. No one else really does manage Kubernetes on-prem. Sure, it's a bitch.
With Anthos now.
Yeah, I mean, Anthos, let's see how that goes. Well, I mean, this is the thing. We're 3 years ahead of Google. Like, cool. That's done really well for us then. It's a big differentiator. Whether this becomes like, let's do like VMware to make it easier, something like that, maybe that's a thing. But on-prem, even though it's a bitch, is a really nice differentiator. If we only did clouds, fine. And then also having that, this whole thing with like giant swarm release versions. I think that's something to be said.
Half our customers have on-prem installations.
Exactly. There's definitely something to be said for being able to have the same thing on-prem and in the cloud, and then sort of with that release versioning, being able to sort of assume that it works the same.
Yep.
That's a big sell for us. So that's how we do installations of the installations and control planes, tentacles, stuff like that. Once we have that base Kubernetes cluster up, we need to install all our services. Excluding managed apps and the VU work, we use a tool called Draftsman. The idea here is essentially that I can just show you. So, for example, this is our Prometheus setup. When I merge a PR, so this is one I merged yesterday. Now it's Blue Peter. I merge it, and then it's deployed everywhere. There's no sort of, I have to wait around for anything like that. I click merge in GitHub, and it gets to all our installations. I don't have to, wait for an SRE to deploy something or do another step myself. That's all sort of done automatically for me. So what this looks like is I merge that to master, And on GitHub, we do some building and we push images and charts. So what this means is we have it's essentially just a folder that contains all the Kubernetes resources that we need to install that onto the control plane cluster. We push that to Quay. Boom, done. That's how we build our applications.
I have a question quickly, if I may.
Boom, go. You don't have to say you have a question. Just say the question, guys.
All right. Well, I raised my hand and then politely...
Raise hand. Nice.
Okay. So, Quay, I understand why. Are there alternatives? Are we... Because, I mean, that's...
Oh, yeah. Yeah. So our requirements here are... We do build on Circle CI, yeah. So this is all on Circle. So our requirements here are technically a Docker registry.
Sure.
So something we can push images to. And I forget exactly what they call it. A Helm chart registry.
Yeah.
So with that, I mean, there are other options here. There are this is a commodity. These are APIs. So like Harbor is another one. Docker Hub takes care of this first bit. Like Quay is just the one we use because it's got some nice features to do with access control, and it's fairly cheap.
I thought Harbor was still something not good yet.
I don't know if it's good or not. I know that it does store images and charts, if you see what I mean. Like if you do hit that API, you do pass the test of can we use you. How do apps fit in with installations? What do you mean by an app?
Who uses apps?
Okay, so this would be managed apps, which is probably like a step above, if that makes sense. Let's do that next. So I love how you just have Spanish men behind. So we have two steps here. We have a sort of build step and we have a deployment step. And that's quite nice because it means you have a sort of separation of concerns. So at the end of the build step, we create GitHub deployments. So I think GitHub has some good docs for how to do this stuff. Yeah. And deployments are just my favorite part of GitHub that gets no fucking love at all. But the idea is that you can create a deployment as an object in GitHub, and then you can attach statuses to it. So actually, I can give you an example. So here, for example, when I see here that Joseph Salisbury deployed to Gauss, Gauss is one of our test installations. So I've created a deployment in GitHub that is for GH Prometheus, for our GH Prometheus setup, and it's for our installation Gauss, which I think is Timo naming it after Hans Gauss, Frederick Gauss, some German scientist.
Yeah.
Then when that deployment is created, Draftsman, which is a program that runs in a control plane, they're continuously asking GitHub, is there anything new I should deploy? Are there any new deployments? It sees it, it then installs, well, actually, it creates, first of all, a sort of pending state and pulls the chart from Quay and installs that using Helm. So again, we're sort of consistently using Helm for Orange as in a test installation. Jess, it's definitely a customer. Yeah, and that's how we use it. Draftsman is our very, I wouldn't say antiquated. You know when a bit of code has been working for a very long time, so it's definitely battle tested, but it's not the most flexible thing in the world. Like, I think I wrote this over a weekend 3 years ago. Apps are a sort of the new fancier way of delivering applications onto, in a general sense, Kubernetes clusters. For us now, that kind of means tenant clusters. So what you're looking at is, I mean, you've probably all seen this at this point, haven't you? My VPN's not on. But in Happer, the sort of apps catalogs. And the idea here is that you can one-click install, say, Datadog. Let's go with that. So I can click, I can go install it here, and boom, we're done. So in terms of like customers, this is, that next step on top of Kubernetes. They can just one-click install stuff into clusters. Technically, that's working by the web UI. I think GSCTL will support it eventually. I don't see why it wouldn't, but I know currently there isn't there. Making a request to the API, which then creates a custom resource in the control plane Kubernetes cluster, which is then reconciled, and this appcr references the sort of general, I want this app installed on this cluster in a sort of high-level way. App operator takes that and sort of makes it a bit more concrete, saying it's this version, which is being installed in this cluster, and this CR is actually in the tenant cluster, so it's already sort of made a switch. Child operator then installs it via Helm. Boom. In future, we will probably use this for most of our deployments. So Vue uses a lot of this stuff. So Vue, for example, is using appcrs and app operator and child operator. We're just creating them a bit differently. Yeah. With regards to
Joe,
yep.
Let me ask about about updates in a wider scope. I mean, like first scope is applications and stuff that we have running on the control plane, right? Is that updated by Drotsman like entirely? So everything that runs there is handled by Drotsman?
So any service that runs in the control plane currently will be updated by Draftsman. Yes.
Okay.
Not the control plane itself, not like the actual sort of Kubernetes cluster.
Yeah. Next thing, updating Kubernetes clusters themselves
is a whole separate bitch. Yeah.
I would almost say a separate goal. Because I don't know what to do.
And one more area is application updates, right?
So for managed apps.
Tenant clusters.
Yeah. Okay.
Managed apps on tenant clusters.
Okay, we can go through this. This is probably quite useful. On the control plane, everything is still being done with Draftsman. In the future, this will be a mixture of Vue managed apps. This kind of work we're doing now. Applications should all be managed with managed apps. So if I remember correctly, the way this works is that either you as a user can go through here and update your appcr from, say, version 1 to version 2. And that kind of goes through the path. You know, the appcr is reconciled into a chart CR. Oh, shit, I'm just deleting stuff now. The appcr is reconciled into an appcr, into a chart CR, and then that's installed. And so I think there's a workflow there that ends up using like Helm upgrade, if that makes sense. I think also if you are within the same, so here where app operator is talking to registries, if you're, this is getting a bit technical, but within the same minor version, so it'll automatically update stuff from like say v010 to v011. Yeah. So once this is available on the registry, it'll actually just update the chart CRs. So those happen fairly seamlessly.
Joe, I have a question. Why do we say in the control plane and not in the control planes?
That's quite a good question, actually.
Because,
Because what?
Because when I first joined, I didn't realize there were multiple control planes because everybody referred to the control plane. But there's not. There's lots of control planes.
I think it's because the control plane is our singular product that is distributed amongst many customers. So we don't have multiple planes. We have a plane that is kind of replicated. I think.
Yeah. In the control planes.
And if we make a change to one control plane, this change is just copied across to all the installations, the control planes and all the installations.
So ideally, yes. Practically, some control planes have some slight differences.
This is my control plane. There are many like that.
Yeah, it's kind of weird, actually. We should probably say in the control planes. Whatever.
Yeah, because that's really thrown me. And like tenant clusters, they're not all copies, are they? They are the tenant clusters.
So if you are within the same version, so like a v8.2.0 should look the same as a v8.2.0.
Right.
There will be different workloads. because customers define their workloads per cluster.
Gotcha.
So it's that separation between the sort of what's running on the cluster and what the cluster looks like, if that makes sense. So they should all look the same, but they'll have different workloads because different customers. Yeah, that's weird. We kind of should say control planes. That's blown my brain a little bit. For updates of Kubernetes clusters, I will not be able to give you a good in-depth description. You want to talk to like one of the CAS platform engineers because they will do better jobs than I will. But I can give you a fairly good high-level view if you want to get into it. So I have a resource that describes a, let's say, AWS cluster.
Joe, I think you just lagged a bit, at least for me. Could you start again?
So let's go into updates for Kubernetes clusters. You probably want
Before we do,
Oh, yeah.
that control plane thing. Like I've been reading about the architecture, and I thought there was one control plane because even when I read about it, it just says it just refers to singular rather than plural.
So there is one control plane per installation, if that makes sense. So that's probably why we only ever refer to it in the singular.
But do you think customers should know that we have one per installation?
We do make it really clear.
I think they probably do know that they have like several, if that makes sense, because you have like a separate Happer URL and everything.
All right. Okay.
Show the URL quickly with one of the.
Yeah. So like
there's one.
We'll say, for example, I can't get to Asgard. Fine. So Gorilla, that's one of our installations. Gauss, that's another one. This is Anubis, which is different to. It's like a different URL than Asgard, which would be another Adidas installation. And like the clusters and stuff are different. I reckon they're probably aware of it. Or maybe we do want to make sure they're not aware of it. I don't know. That's future stuff.
I would go so far as to claim existing customers are, and we make it clear in the tech demos and the intro calls to customers that it will be.
Yeah, I'm not certain if we've had how many customers we've had that don't sort of follow that part.
Quite.
It's interesting.
It comes up sometimes as an initial question because competitors out there do have shared stuff.
Definitely.
That is another differentiator. Sure.
Oh, that was actually a question somewhere, wasn't it? Why separate installations? So we probably could operate in some kind of way where we have shared control planes, or we have one control plane, or something like this. We would always have to have, or be able to have, separate control planes for on-prem, just because of like connectivity issues. Having a separate full installation per customer starts giving us some really nice benefits in terms of failure modes. So if, say, for example, the Adidas on-prem control plane dies, the Vodafone is not affected, like, at all. It doesn't really matter to them. And there's also some benefits, some possible benefits, because I'm still questioning this slightly internally in my head, about latency. Like, if you're managing a Kubernetes cluster and it's in Singapore, and the control plane is in the opposite of Singapore, like Frankfurt, it takes a while just because of the distance for network connectivity there. So having it closer means things are more reactive. For upgrades, this is very cool and kind of complicated. So I'll just give it on like a big high level. And I would really recommend finding one of the CAS team or just any platform engineer, and they'll be able to give you a better explanation. So every custom resource that describes a cluster also has a version as a field. So I forget exactly which version number this is, but let's just go with some sort of demo one, like 840. When the AWS operator reconciles this custom resource, it internally looks up the code base for 840 and then reconciles against the AWS API. So that probably ends up meaning a specific like CloudFormation stack, essentially. When we then upgrade it, we change this to, let's say, 850 via the API. which then reconciles with the AWS operator, which looks up for the code base for 850 and reconciles it. So like this, which will then talk to, again, the AWS API, which will then make a update to the CF stack with the new, what's the name I'm looking for? CloudFormation stack definition thing. You know what I'm talking about. In a really high level. There's some integrations here as well with like the node operator for draining. So like that we don't tear down a node before we have completely drained it. There's also some stuff to do with renewing certificates, I think. I don't remember this well enough. But was that a start, Lukasz? There we go.
I have a question for the architects here who've recently joined the company. Out of everything that Joe just explained, what percentage do you already know? Did you already know?
Press 3 already, Christ.
Hello? Can you not hear me? Hello?
I think they're holding back.
Oh, right. Out of interest.
Well, I guess we've lost Cornelius at some point, haven't we?
Well, I mean, look, you don't have to put anyone on the spot. This can
No,
be taken
I'm just
aside.
interested, like, just to gauge, because... Okay, no worries. I knew 90%.
Yeah. Do we have any? Oh my god, how have I talked for an hour straight? Fuck me. Do we have any open questions that people want to cover before we call it?
I gotta run. Thanks, Joe.
No worries. Sai, can you make the? No worries.
Yeah.
Cool.
Joe, would you be able to send this picture that you're drawing to me, please, so that I can...
I will just throw it into SIG architecture.
Thanks, because we have our
Now.
PO recap on Friday, and I'd like to
Sure.
discuss this out loud, if that's all right. Susanna and
No worries.
just to ensure it's digested.
Whatever. I'll get it in there later.
Yeah.
Any last questions? Anyone got burning desires? Not desires. Fuck off.
Not for this call, dude.
Call me later. Cool. Then let's call it a day.
Yeah, thank you so much.
Thank you,
That was
guys.
super helpful, Joe.
Well, okay, sure. See you, guys.
Sweet. Cheers, Joe. Ciao.
Ciao.
Bye.